So now we're going to start with a new chapter which is called as applications of trigonometry. Now trigonometry, when we studied the first chapter, we have studied about a few things which is called as sine, okay, cos and tan. Okay, and we also saw that these are the measurements of an angle. So it is given like this. So sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, tan is opposite upon adjacent is what we know. Okay, then we have also studied that trigonometry can be only applied to the right angled triangle. Very well enough. We know it by so far. Okay, now what we are going to see is now what are the applications like sine, cos, tan. When we are studying it for the very first time, we do not understand where are we going to use this, what is the use of studying all of this sine, cos, tan. Algebra wasn't enough for us to simplify it. No, algebra was actually not enough for us to simplify many concepts of physics and chemistry as well. Okay, you may say like how chemistry is like talks about the atom rotation, sorry, the electrons and rotation of the electrons and all, the speed with which it is going, the angle with which it is moving. All of that is being considered and studied with respect to the trigonometry itself. Okay, major laws of physics that we are following today to go to space or for the construction purposes, architecture, engineering, all of that require trigonometry to the core. Okay, so trigonometry is not just applicable for now. Up till the 10th standard, we understand that trigonometry is only available and applicable to right angled triangles, but it is not restricted to right angled triangles alone. Okay, now for now let's just stick by right angle triangles only. So when I go with it, this is the right angle triangle, this becomes the hypotenuse, and this becomes, if the angle is here theta, this is called as the adjacent and this will be called as the opposite, is what we know. Okay, but if I have something like this, I'm drawing the same figure and taking my angle onto this side here theta, then this becomes my adjacent, this stays as my hypotenuse, and this goes as my opposite, is what I understand. Okay, well understandable. Next, the side which is next to the angle that we are considering is always the adjacent. Okay, the side which is next to the angle is the adjacent, the other one is the opposite, this is the opposite, and hypotenuse is there. Now where are we applying? This is being applied in, okay, so let's consider where we are going to use this sine, cos and tan, how specifically to the 10th standard of CBSE, NCERT and all of that. Let's see where we can apply it. So we are talking about this angle, this specific angle is considered to be the angle of elevation. Okay, suppose there is this ground, there's some person standing here, and there is Burj Khalifa in here, the world's tallest building. So what do? You have to lift up your head and then you are going to look up to it, isn't it? So this is called as, from the horizontal, this angle that you are creating to look at the top of Burj Khalifa, this particular angle is called as theta, named as angle of elevation. What is it called as? It is called as angle of elevation. Now in here, this angle is also called as angle of inclination. What does the term inclination means? How inclined it is. Okay, it is also called as angle of inclination. This talks about how inclined a surface is. Okay, now when I'm talking about this, now you may say that, how is the person standing on the ground compared to Burj Khalifa? This point is actually, a human is very tiny in front of it. Okay, so we are considering the same thing in here. We are considering us to be tiny and Burj Khalifa being too tall. We are considering like this. Okay, let's consider what are the different type of questions you will have. Okay, there's a wall and there is this ground. You have to reach a certain point onto the wall, and you're using a ladder. And how are you going to use the ladder? The ladder will be kept slant, isn't it? So that you climb up the ladder and then you're able to reach that particular point, isn't it? So here again, if you look at this figure, it appears to be a right angled triangle, and this is the wall. Okay, this is the wall, this is the ladder. Now this ladder is at the position of a hypotenuse, and this angle is called as angle of elevation. Okay, this is the angle of elevation, I know. Okay, and this is the height of the wall. Okay, this is the wall height. Okay, which will now become the opposite side, and this side, which was the distance between the wall and the foot of the ladder, this side will become the adjacent. So you have opposite, hypotenuse, and adjacent. You can use any of the three trigonometric identities that we have. Okay, and to restrict you, we are only going to use sine, cos, and tan. We are not going to use any other thing to confuse ourselves. Okay, cot, cosecant, and secant, we are not going to use any such of that. Now let's consider another question that will be there, is that, a man is standing. Okay, the man's tall now on the floor, this is the ground, and the shadow is there. Where will the shadow be? The shadow will obviously be on the floor, isn't it? The shadow goes like this. So this point to this point, this is the head of the man, this is the head of the man, and here is the head of the shadowed head. Okay, so this is called as, again, this angle that is there between both of them is also called as the angle of inclination, or it will be called as the angle of elevation. Okay, and so this is the man, and we have the shadow in here. Okay, and this angle that we will have is a right angled triangle. Again, this appears to be a right angled triangle, so we can use sine, cos, and tan in here to solve our questions in here. Let's get to the example one of the chapter, because unless and until you understand a few examples, it will be difficult for you to understand the exercises. Usually what I do is I solve the exercise, then I say that you can follow up the examples, but here let me just start with the examples so that it becomes easy for us to go ahead further. Okay, now looking at the question, it says that a tower stands vertically on the ground. Okay, now as I'm reading the question, I am going to draw the figure for this one, because it would be more easy for me to understand it with the figure, to know how to solve it. So it says a tower stands vertically on the ground. Okay, there's the ground, then there is a tower standing vertically on it. Okay, then it says from a point on the ground which is 15 meters away, from a point on the ground which is 15 meters away from the foot of the tower. Okay, this is the tower. Okay, and this is the foot of the tower. From here, 15 meters away, you can take 15 meters here, you can take 15 meters here, does not matter. Either this way or that way, 15 meters doesn't matter. Okay, so this is point at the ground which is 15 meters away. The angle of elevation of the top of the tower is found to be 60 degrees. From this point, if I'm looking at the tower, it is found to be 60 degrees. Okay, then it says this distance is given as 15 meters. Find the height of the tower. I do not know how to find the height of the tower, but to me it appears to be a 90-degree right angled triangle, wherein this is the hypotenuse, this becomes the adjacent, and this becomes the opposite, because the angle that we are talking about is this. Okay, now when I was talking about the angle of elevation is always made from the horizontal. Okay, you need to have a straight line, only then the angle of elevation can be made. Okay, now further going ahead, this is the first part of the chapter. Okay, you will have something else also called as angle of declination. Okay, declination, sorry, okay, now here that means you are looking down from some particular point, so that we'll discuss a little later in the second part or something. Let's just concentrate here. Okay, so we are having this particular figure. Okay, now I know hypotenuse is the value of hypotenuse given, no. Opposite given, no. Adjacent given, yes. Angle is given. So we have sine, which is opposite upon hypotenuse, cos, which is adjacent upon hypotenuse, tan, which is opposite upon adjacent. So he's asking me to find the tower height. This is what I have to find out. This is given to me. Adjacent is given to me. Hypotenuse is not given. Opposite is not given. Okay. And the angle, if I use this particular thing, the adjacent thing, some people will say, why not sine? Because opposite height, hypotenuse are both not given to me. Cos, why not cos? Adjacent is given, hypotenuse is not given. So first we will have, and I can use this cos. First I will have to find the hypotenuse. Then after I find the hypotenuse, I have to use sine, because opposite is to be found out. To find the opposite, I need to go with the hypotenuse. So pehle cos karna padega, then I have to go with the sine. So it will become too lengthy for me to simplify the question. So what I'm going to do is, I have adjacent, asked about opposite. So I'll choose the one which has adjacent and opposite in the formula. So let's do how we can simplify this thing. So to simplify this thing, what we are going to do is we are going to write down the values, the pieces of information which is given to me. So what is the height of the tower given? Not given to me. So I'll write height of the tower. Let us be height of tower is unknown to me. So let that be equal to h. We consider the heights as h meters. Okay, that's there. And we'll name this figure as A, these points as B and C. So therefore the tower AB is equal to h meters is what I get. Okay, then the distance between, distance is given as this is the distance. It is given as BC, which is equal to 15 meters. Okay, and the theta, angle of elevation, is given as 60 degrees. So in triangle ABC, this is the triangle that you're considering. In that particular triangle, we are going to apply our trigonometry. So what is the trigonometry that you're going to apply? Tan. Why? Because opposite and adjacent. Opposite as asked, adjacent is given to me. Tan of 60 degrees is equal to opposite. Opposite is nothing but my AB now, upon adjacent, which is BC. So the AB value that we have taken is h and the BC is 15. I know that tan 60 is root 3. So it goes root 3 is equal to h upon 15. So when I send it towards the other side, because I have to calculate h, so it becomes 15 root 3 is equal to h is what it becomes. Okay, you can leave your answer here. That is it. This is what is the thing. Now here, because there was only one triangle, it was simple and easy for us to simplify it. But at times there will be multiple triangles also. But also always remember, break the figure down into simpler triangles, right angle triangles. Apply either of these three and get your answer. That is the only solution that you have. It's very easy compared to the trigonometry chapter exercise, the last exercise of introduction to trigonometry. This chapter is very easy. We are only dealing with sine, cos and tan. No, nothing required, only the values of 0, 30, 45, 60 and 90 for sine, cos and tan. And you don't know how to do it, how to write down these values, that's also completely fine, because we have learned it in the previous video how to write these values down. Okay, so this is the height of the tower that was asked to me to find out, and I'm going to write height of the tower. Therefore height of tower is equal to 15 root 3 meters. Just leave it like that itself. You're not going to rationalize it, you're not going to do anything, you're just going to leave it like that. If there'll come some questions wherein they will ask you to take assumed or consider root 3 as 1.732 or something, okay, but since it is not asked here, just leave it like that itself. Let's move to the second question. Further looking at this particular question, it is this here. Okay, I liked the question. While I was writing it, I was very much fascinated by the question. It says that electrician has to repair an electric fault on a pole of height 5 meters. Okay, there's a pole. The first information that is given, there's a pole of 5 meters. On that, the electrician has to repair a fault. Okay, she needs to reach a point. Okay, she was what fascinated me. She needs to reach a point 1.3 below the top of the pole to undertake the repair work. So below, from this particular point, she is supposed to go down to 1.3 meters. Okay, now she, because feminism and all of that, it's hyping up, and the question is like allowing female electricians, that's why hyped up question. What should be the length of the ladder? I told you now, to reach this particular point she needs to have a ladder, isn't it? She is taking the ladder, and the ladder and the pole will be kept onto the same floor, isn't it? This is the ladder and this is the pole onto which it is to be attached. The complete height of the pole is given as 5 meters. Okay, so if the complete height is 5 meters, 1.3 from the top, how much will this be? This is going to be 5 minus 1.3 meters, which is equal to 3.7 meters is the height of this part of the pole. Okay, now length of the ladder is asked. Okay, fine, I do not know. Then it says, no, length of the ladder, yeah, length of the ladder, such that she has an angle of elevation of 60 degrees. The angle of elevation, obviously, it cannot be here. It is going to be here itself, which is given as 60 degrees in here to the horizontal. Also, how far the foot of the pole is. Now, this distance is also being asked. How far is the foot of the pole should be from the ladder? Okay, so this distance is also asked. Let this be D. Let this, the length of the ladder, be L meters. Okay, and the distance be D meters is what we understand. Okay, now this is the figure that I've got. So let's name the point. Let the pole be named as A. B is the complete pole and C is the point of observation. But here somewhere we are supposed to reach. Let this point be named as some L, because the ladder is reaching here. Okay, so let me just first write down the information. Length of the pole, length of pole is equal to 5 meters. Point to reach is going to be 5 minus 1.3, which is equal to 3.7 meters is what I get. Fine. And then length of the ladder, let the ladder length be is equal to L meters, and distance is given as D meters. Okay, now after I've written down all the information in triangle, now what triangle am I going to take? LBC. LBC. Why not A? Because A, it's not reaching up A, it's only reaching up till L. So LBC is the triangle. Now I have to find this length, I know, which is 3.7, and I have to find, either I can go with D, finding D, or L. Okay, I have sine, cos, and tan. I have, now here the hypotenuse is missing, the opposite is given to me. The adjacent is missing, hypotenuse is missing, opposite is given to me. Opposite is given to me, adjacent is missing, and I have to find both of them. So one after the other, I'm going to take the first one and the second one and find the values out. Okay, so let's go. Sine of 60 degrees, because the angle is given as 60 degrees, is equal to opposite, which is LB, upon the hypotenuse. Hypotenuse is LC. Okay, sine 60 is root 3 upon 2. Root 3 upon 2 is equal to LB is 3.7 divided by LC, we don't know, which is L only. Okay, let's start to simplify this further. So when I simplify it, it goes towards the other side and all. L is equal to 3.7 times 2 divided by root 3. Okay, that becomes how much? That becomes 4 and 1, 2 ones, 2, 3, 6, 7. 7.4 upon root 3 is what you get here. Okay, now we cannot leave the answer as a fraction is what we understand here. Why can we not leave it as a fraction? Because of the fact that it is going to be it is not a rational number. Having a fraction, it is not acceptable to have a rational number at the bottom. So what do? We try to rationalize it, and when I'm trying to rationalize it, I get something in here that goes as rationalizing means multiplying and dividing by root 3 is what I'm doing here. So that becomes 7.4 root 3 divided by root 2. Root 3 times root 3 becomes 3. Now let's go reducing this fraction. Reducing this fraction means I have to 7.4 divided by 3 is what I'm supposed to do in here. Okay, this 2 will actually divide. 7.4 divides with 3. 3 to 6, 1, and bring the 4 down. 3 fours, decimal is there. 3 fours 12 and 2 decimal is already there. Take a 0. 6 times 18, and so it will continue to go ahead. So it is going to be 2.46 root 3 meters is the length of the ladder. Okay, now because L is nothing but the length of the ladder is what we have taken. Then what we are going to do is they have asked the distance between these two as well. So to find the distance opposite and adjacent we are talking about, we can go with tan. Now I have my hypotenuse and opposite, but I have to find the adjacent. So to find the adjacent I can go with cos as well. So let's go with tan itself. Okay, so tan of 60 degrees is equal to, again the same thing I'm going to take. This is in triangle again, LBC. Okay, tan of 60 degrees is equal to opposite upon the adjacent. So opposite is nothing but LB upon adjacent is BC. So this becomes tan 60 is root 3, I guess. Yeah, root 3 is what I have for tan 60, and is equal to LB height is 3.7 units is what I have, and then further this distance is there, so D is missing in here. So what do I do for this one to simplify it? I am going to again send this D towards the other side. It becomes D is equal to 3.7 divided by root 3. Again I have to factorize it. It becomes root 3 upon root 3 is what I'm going to do. That becomes 3.7 root 3 divided by 3. Now I will multiply it further. Sorry, I will divide these two things. 3.733s, 3 ones are 3. I get 0.7 point. I'll take 2 times 6, 1, and decimal is there 0. 3 times 9, and so the answer is going to be D is equal to 1.23 root 3 meters. Root 3 I did not use it, so root 3 meters will come in here. You can leave your answer like this, or and your answer like this. Okay, or else you can just substitute the root 3 value. That will be 2.46 into 1.73 and multiply and get the answer and write it down in meters for this one. Likewise here also I am going to do the same thing. 1.23 times of 1.73, and whatever answer you get, that will be your answer for the distance between the 2 points that I have. The distance is found, and the length of the ladder is also found from this particular solution. Now, starting with this question, it says that an observer 1.5 meters tall. Observer 1.5 meters tall. So what do I understand? There's a person whose height is 1.5 meters. Okay, so this is 1.5 meters height of a person. Is 28.5 meters away from the chimney. Okay, there's a chimney and the distance is 28.5 feet because it is 28.5 meters away from the chimney. The angle of elevation of the top of the chimney from her eyes is. Now all this time what we have done is we have been taking the angle of elevation from the ground. for the chimney or anything. But now it says the person is 1.5 high, and from the eyes of the person, obviously the eyes are in the head, so from this point the angle of elevation is given to me as 45 degrees. So what is the angle that is given? It is given as 45 degrees. Okay, what is the height of the chimney? Okay, so chimney height is what I do not know. I have to find this out. So let's just start the solution. Now that the figure is completed, let's just start writing the information that is given to us here. Okay, so considering the information that is given to us here, height of the person, height of the observer or the person is going to be, observer is going to be 1.5 meters high. Okay, distance between observer and chimney is given to me as 28.5, and then it is given to me that angle of elevation. So let's name them as A, B, C and D. And okay, fine, so angle A, B, sorry, A, D, A, and I will have to get this angle completed, right? Now chimney को अगर देखें, if you look at the chimney, if this is 1.5, this will also be 1.5, isn't it? So let's just name this as some point P. Okay, I'm naming it as some point P. So what's actually happening in here is, if you look at it, I am just going to consider this particular triangle because I know this height is 1.5, so also exactly on the other hand side it is going to be 1.5 itself, isn't it? So we'll say, we'll consider height of dp is equal to height of chimney. We will write, because this is what is being asked, chimney is what I'm supposed to find. Chimney is equal to h meters, and this is the complete height that we're talking about. Now from this complete height, I know a certain part is 1.5, isn't it? So I will also write the height of the chimney is dp plus pc, dp plus pc, isn't it? And the pc is equal to the height of the observer, which is 1.5 meters. So we know height of the chimney, height is equal to dp or pd plus 1.5 meters. Now we're just supposed to find out this height, which is dp. And looking at the triangle, so what we're going to do is, in triangle ABD, I know if this is 28.5, this will also be 28.5. Okay, so this side becomes, what does it become now? It becomes the adjacent, and this becomes this height I'm supposed to find out. This becomes the opposite. So what am I going to use here? I'm going to use my tan in here. In triangle ABD, tan of 45 degrees, this is the only angle that I have, is equal to opposite upon adjacent, which is dp upon AP. And AP I know is exactly equal to BC, isn't it? AP is exactly equal to BC, which is 28.5. So dp will remain as it is, and I'm going to write 28.5 in here. Tan 45 fortunately is 1, isn't it? So it becomes 1 is equal to dp upon 28.5. That will make, I'll send it towards the other side, it becomes 28.5 is equal to dp. Okay, so automatically the height of the tower, height of the chimney is going to be how much now? Height of chimney, which is h meters, was equal to dp plus pc. dp is 28.5 plus pc is nothing but the height of the observer, so that goes as 0.5, and that becomes 30 meters is the height of the chimney, is what I get in here. 28.5 from the dp, and pc is given to me as 1.5 in here, so that adds up to 30 meters is the answer for this one. Okay, now let's consider the fourth example question. It says that from point P on the ground, okay, there's a point P on the ground. Now always what I was doing is, when I was drawing the figures, I was considering the figures on this side, okay, the observer on this side, and the chimneys and towers and all of on this side. Now let's consider the observer to be here, okay. let's just change it a little bit. The observer is here and the chimney or whatever is over here. From the point P on the ground, this is the point P on the ground that we're talking about. P on the ground, the angle of elevation of the top of a 10-meter tall building is 30 degrees. Okay, there's a building, okay, which is 10 meters tall. So I'll write it as 10 meters in here. And the angle of elevation of this top of the building is 30 degrees is given to me. Is 30 degrees. Okay, fine. So as and how I'm reading, I am drawing the figure. Okay, so that it becomes easy for you to do it. The next is a flag is hoisted at the top of the building. Okay, obviously at the top of the building you're going to hoist a flag. Okay, so the flag is somewhat hoisted like this. Okay, then at the top of the building, done. And the angle of elevation of the top of the flag staff is from P. From the same point, the top of the flag staff is being observed, and that angle of elevation is coming out to be 45 degrees. So it goes something like this. Okay, so let me just go and draw this thing. Okay, so this is the point P that I have, and the angle of elevation. Angle of elevation of this flag staff, it is not just this angle, it is the complete angle which it is talking about. Okay, 45 degrees. Find the length of the flag staff. Okay, now this is the length of the flag staff, which is unknown to us and to be found out, and the distance of the building from the point P. Also, I need to find this distance that is given to me here. So let's just mark it something like this. This is the distance. D meters is the distance. Now, first of all, if as per the question, if I go to find the flag height, the height of the flag post or something, I would have to take this complete triangle. Okay, let's just, this is the figure that is there. Let's make it a little simple on this side. Okay, this angle is given as 45 degrees, and there is a point, the building is over here, and that is again given to me as 30 degrees. Okay, this is given as 30 degrees. This is the point P on the floor which is being observed. This is the point A, B and C. The BC is given to me as 10 meters already. BC is 10 meters, I know. This height I do not know. So if I am taking this complete triangle 45 degrees, okay, now in trigonometry I have sine, which is opposite upon hypotenuse, cos adjacent upon hypotenuse, tan is opposite upon adjacent. So if I'm using this complete thing, okay, do I know the hypotenuse? Do I know the length of the hypotenuse? Hypotenuse I do not know. So the two options where I have the hypotenuse is ruled out. Okay, do I know the adjacent? Adjacent also I do not know. I do not know the adjacent also. Okay, adjacent also I do not know. Do I know the opposite? I know the opposite, but only for this particular triangle. For this particular triangle only I know the opposite value. Do I know the angle? Yes, I know the angle for both of them. All both the things are 30 degrees and 40 degrees. I know the angle. Theta I know. So if you consider sine, opposite, hypotenuse, there are three values, and out of which one can be unknown, isn't it? We can either not know the angle, and opposite and hypotenuse is given, we can find the angle. Okay, or we cannot know the opposite, the other two are given, we can find it. So one unknown should be there. So here I have 10, an angle, and this can be the unknown. So I am going to apply here the tan value to get this distance first. In the question he said find the length of the flag post. If I go to find the length of the flag post, which is this part, I do not know this, I do not know this. Only one angle in this value would make it quite difficult for me to simplify. Okay, it would make it quite difficult for me to simplify. So what we are going to do is we are going to what we are going to do is we are going to find this first, the distance between the observer, the point P and the building first, with these two things. Okay, so let's first put down all the information that I have. So this is a mandate thing. So height of the building, height of the building is going to be 10 meters, which is as per us is BC. Okay, then after I know this, height of the flag, height of the flagstaff is AB, is equal to unknown, so let it be H meters. Okay, so I'll write it as H meters here. Okay, distance between distance of observation is equal to, I don't know what this is, so we took it as D meters. You also will take it as D meters, which is CP, which is going to be D meters. Okay, now after that I have seen that I am taking this particular triangle. So in triangle BCP, opposite and adjacent angle is given to me. So tan of 30 degrees is equal to opposite BC upon CP. Do I know the tan 30 value? Yes, I know the tan 30 value. Tan 30 is 1 upon root 3. So we will take it as 1 upon root 3 is equal to BC is 10 divided by CP. If I have to simplify it, it becomes the CP, it goes towards this side, is equal to 10 root 3. Root 3 value in the question is given as 1.732. So we are going to replace it and write it as 10 times of 1.732, which turns out to be 17.32 meters. Okay, so the distance I know now is, therefore I'll write distance is equal to 17.32 meters. Now done. Now I have to find this thing. I have to find this, right? To find this, what I'm going to do, I cannot take this triangle ABP, because this is not a right angled triangle. If it was, I could have used sine cos tan, but here this is not a right angled triangle, so I cannot use sine cos tan here. So what I'm going to do is I am going to use the big triangle. What I'm going to do in triangle ACP I'm taking again 45 degrees. Now I know this value, I can find this complete value, isn't it? So that's what I'm going to do. ACP tan of 45 degrees is equal to the opposite. What is the opposite here? The complete opposite. So let me just write down the opposite. AC is there. AC is the opposite, divided by CP. What is the CP value that I've got? The CP value that I've got is, I'm not going to take 17.32, because this will make my complications a little difficult. Or you can just, here why I'm saying is, in questions, in the examination, you'll get questions where you can cancel the root 3 off. So depending upon the application in here, either you can take this or you can take this, because here it is tan 45. I know tan 45 is 1. Complications will not be difficult. But supposedly there is again another 30 degrees. So it becomes root 3, no? It would become something like this. Tan of 30 degrees is equal to AC upon CP. It would be, right? So tan 30 is 1 by root 3. And again, I know AC will repeat like this. CP is 10 root 3. So when I send it towards the other side, it becomes 10 root 3 upon root 3. So if this root 3 can get cancelled, and AC will be 10. This is just an assumption that I'm showing. Okay, assumption and an explanation. So that is why it's better to take 10 root 3 than 17.32. That's what I'm trying to explain in here. Okay, but since I have 45, I know it is 1, so it will be easy. But I know AC is a combination of, the AC is a combination of AB plus BC. AB plus BC upon CP, which is 17.32, is what I know. So tan 45 is 1, which is equal to AB plus BC is 10 meters divided by 17.32. Sending it towards the other side implies it becomes 17.32 is equal to AB plus 10. Now when I send it towards the other side, it becomes subtraction. 7.32 will be the AB. This is in meters, that is the height of the flagstaff. Therefore, flagstaff height is equal to 17.32 meters is what we are going to write. Okay, so questions as such will come. This is not difficult, it's just that how you're using it. It looks too lengthy to solve, but it's just that two triangles you're using and you're simplifying the complete thing off. Only using sine, cos and tan, not even cosecant and secant and cot. Practice it, it will be very easy for you to simplify. Now going ahead with the fifth example question, it is, if you read the question, you go like, what does it say? But it is simple English again and again. I'm saying the questions are actually in simple English. Just pay a little attention and you would be able to understand it. The shadow of a tower standing on a level ground. Okay. Shadow is not standing. Now, most students will interpret that there is a shadow of the tower. No, sorry. The shadow of the tower is standing on a level ground. So the shadow is standing, they'll consider. No, shadow is always on the floor. Okay. This is a tower standing on the level floor. Okay, this is the tower that's there. Now this tower is casting a shadow, obviously. So how is the shadow will be? The shadow would be something, the top part would come here, isn't it? When shadows are formed, this will be reflecting here and the base will be anyways like this. So the building would be something reflected like this. Okay, so let's consider, because he said there's a tower. So this is the tower that I have. Okay, and this is the shadow. Okay, the shadow of the tower standing on a level ground is found to be 40 meters longer when the sun's altitude is 30 degrees. So when the shadow is getting, this is the normal shadow part till this point I drew the shadow. But then he mentioned that the shadow is increasing 40 meters longer. Okay, it is growing further 40 meters. Further 40 meters the shadow is growing when the altitude of the sun is, okay, there's sun also. There's the sun. Okay, so when I have the sun is 30 degrees, altitude is 30 degrees. So that means at a height of 30 degrees from the tower. So are you going to go like this, or how you going to go? It becomes difficult. Sun is up in the air. Are we can we see the angle of elevation of the sun? Do you know the distance to the sun? If I'm talking about angle, this is the sun here. Angle of elevation to the sun, do I know it? Do I know the height of the sun? No, I don't know. What is the distance? I know. I don't know anything. So sun is just an imaginary thing that he's talking about. What he's concentrated upon saying is, now when the altitude is 30 degrees, means when the height is 30 degrees from the top of the shadow. Okay, so we are least bothered about the sun. We're just going to talk about the angle of elevation. Now the shadow is, what did he say? The shadow of the tower standing on a level ground is found to be 40 meters. There's a shadow, this part till here I drew. Then it said the shadow is getting 40 meters longer. So where will it grow? It will not grow higher, no. The shadow will grow like this only. So 40 meters longer it is going. Not the complete distance from the normal shadow to the point of extension is 40 meters longer when the angle of elevation is 30 degrees. Okay, when the sun's altitude is 30 degrees. So the sun's altitude is nothing but this is what he's talking about. When this angle is 30 degrees, it is so. Then when it is 60 degrees, so that means the older one is 60 degrees. Okay, so the older one is 60 degrees. The previous angle of elevation or the altitude of the sun was 60 degrees. So the sun, wherever it was, the shadow, the top's reflection and the bottom's, the top of the tower and its reflection had an angle of 60 degrees. And the top of the tower and the angle of, the top of the shadow is making an angle of 30 degrees now. Now, when you look at it, does it not look like a right angled triangle? It does. Then it says, find the height of the tower. Okay, now. Here, again, I told you just in the previous question, if you have sine, it is opposite hypotenuse, cos, adjacent hypotenuse, tan is opposite and adjacent. Now, if I want to find the height of the tower, this is what I have to find out. I don't know the height. I know the angle, theta I know. Opposite and adjacent, both I don't know. I cannot apply this, isn't it? If I'm taking 30 degrees also, still this and this both are unknowns to me, isn't it? It's all unknown to me. So how do I find this actually? Like, what can be the possible solution? To find this question, what we're going to do is very simple rule. Let's go with everything as unknown itself. Okay, let's first name this particular figure that I have into our alphabet so that it becomes easy. Okay, this becomes A, B, C and D. So let's write down height of the tower. What are the unknowns? Height of tower is equal to h meters, which is equal to dc, or else you can write which is dc is equal to so on and so forth. Okay, angle of elevation, elevation, there's another name for it which is also called as inclination. Okay, angle of inclination is also going to be 60 degrees. When it is 60 degrees, do I know the length of the shadow? Implies shadow is equal to BC, which I do not know, so I'll write it as x meters. Height we are taking as h meters, so distance we'll take it as d or x. Okay, then when angle of elevation or inclination is equal to 30 degrees, implies then the shadow is becoming, how much is the shadow becoming? Shadow is AC, which is AB plus BC, which is 40 plus x meters. Now let's take any one triangle, because here everything is unknown, isn't it? Everything is unknown to us. So if you take this or you take the bigger one, it doesn't make much difference. Okay, let's just write 40 meters here. This is x and this is h. Okay, so we'll write in triangle. I'll take the bigger one first. A C D. ACD, this is the triangle that I'm taking, implies the angles are given as 30 degrees here and 60 degrees here. So we'll do is tan of, again I have to go opposite adjacent, because hypotenuse का तो नाम नहीं लिया, बात भी नहीं किया. They have not even mentioned about the hypotenuse. So we cannot take sine and cos. We can only take tan. So tan of 30 degrees is equal to opposite, which is DC upon AC. Okay, I just know DC is equal to h meters from here. H and AC is equal to 40 plus x. 40 plus x. Fine. Let's simplify and keep it here. Tan 1 by root 3 is equal to h upon 40 plus x. What did he ask in the question? He asked to find the height of the tower. So we will make this as the subject. I'll send it towards the other side. It becomes 40 plus x upon root 3 is equal to the height of the tower. Let this be, because there are two unknowns, let this be equation 1. Okay, Then I will go with in triangle BCD. Now I'm taking the smaller triangle. Tan of 60 degrees is equal to DC upon BC. Okay, so tan 60 is how much? Tan 60 is root 3 is equal to DC is H and BC is X. So I'll send it towards the other side. Okay, when I send it towards the other side, so when I send it towards the other side, it goes like this. It becomes root 3x is equal to my H. Very understandable what's happening in here. Now I get something again in H equal to H. This is my equation 2. I know this is equal to H, this is equal to H. Ultimately, this part will be equal to H, will be equal to this one, right? Equating 1 into, okay, you can write equating 1 into and all of that. So what is happening over here? 40 plus x upon root 3 is equal to root 3x is what I get, because h is now cancelled. When I simply send it towards the other side and simplify it, it becomes 40 plus x is equal to this into this becomes 3x. I'll bring this here, it becomes 40 is equal to 3x minus x, which is equal to 2x. 2 1 times in 20, so I get x is equal to 20 meters. Now I know that when x is 20 meters, then my height, if I substitute here x and all, it will be too difficult. So where am I going to substitute it? I am going to substitute it here. Okay, substituting into implies root 3 times of 20 is equal to h, which is 20 root 3 is the height of the tower. This is what was asked me for me to show. Now I want you to rewatch this question and then do it so that it becomes easy for you to understand again. Because there were two unknowns, we used one triangle, took down an equation, used the other triangle, took down another equation, equated both of them to get the value of x. Once I get one unknown, I have substituted it into the simple most equation and got the value of the height of the tower for me. Okay, now I'll stop the questions of examples here and switch to the textbook in the next video.